Hello, this is the luckiest maths teacher in the world, and today we're going to learn area of a parallelogram. Okay, so we did area of triangles and rectangles last term. Now we're going to do some more on parallelogram. So what is a parallelogram? Well, it's actually very similar to a rectangle, because here's something that's going to blow your mind. All rectangles are parallelograms, but not all parallelograms are rectangles. I know, mind blown, right? So let's just look at a rectangle. So we know how to find the area of a rectangle, okay? I'll just move that around. Nice and easy. It's just the length times the width. A parallelogram, a general parallelogram, looks like a rectangle, but it's just on a slant. So here on the screen now, I'll just put parallelogram. So A, B, C, D, here is a parallelogram. So you can see it sort of looks like the rectangle on the left, but it's just slanted a little bit. Now, just so we're 100% clear, we did do this earlier in the year, but just so we're clear, this and this symbol here mean that those two lines are parallel, and also these two lines are parallel. Okay, it's the same in a rectangle. These two lines are parallel, as are these two lines, okay? That's the definition of a parallelogram. It's a four-sided shape with two pairs of parallel sides. Okay, so how are we possibly going to find the area of this shape? Well, let's look at an example. So hopefully you can follow this. So let's say we have the two parallelograms that I just put on the screen. Now, they're actually the same drawing, top and bottom. So here we have a parallelogram because it's a four-sided shape, and there are two pairs of parallel sides. What we can do though is we can draw a line down here that is perpendicular to the base. Remember, perpendicular means at right angles to. And then what we have in here is a triangle. We then move this triangle, so this triangle here, over to the other side of the parallelogram, which is what we have here. And now we have a rectangle, right? So this parallelogram basically has the same area as this rectangle down here. That's great, because as I told you, you already know how to find the area of a rectangle. So we've called this pronumeral B. Thank God we've done algebra, because now you know that it doesn't matter whether I call it B, X, Y, whatever. And we have H here. B usually stands for the base and H for the perpendicular height. So the area of a parallelogram is just B times H, the base times the height, because this is a rectangle and we're just timesing together its length and width, okay? If you like, this is the exact same formula as the area of a triangle, but there's no divided by 2. So it's also the area of two triangles put together. Now that's because I can easily cut a parallelogram in two, like I've just done to the one at the top right, and I've got two triangles, okay? So these triangles each have an area of base times height on 2. They're identical, notwithstanding my bad drawing. So the total area would be 2 lots of base times height on 2, and hopefully, since we've done algebra, you realise that this is just BH by itself. Okay, easy as. So let's look at some examples where we're actually going to calculate the area. Okay, so let's look at the parallelogram that is now on your screen. It is a parallelogram because it's a four-sided shape and it has two pairs of parallel lines. Just in case you forgot, by the way, parallel means the two lines will never meet at any point, no matter how long. If they were to go on forever and ever, they'd still never meet. So, let's look at how we find the area of this. So, we have area equals base times height. So this is exactly the same formula that I just used. Now what's tempting for some people is to just say, oh yeah, there's three numbers on the screen. Yeah, it's area. I'll just multiply them together because I'm a 12-y. That's not how we actually do it. You actually need to go and find what is the base and what is the perpendicular height. We don't want the slant height, okay? We only like straight things here in area. So this is the straight or the perpendicular height. This is the base. Now, how do we know that 15 is the base and not 7? I mean, if we turn this parallelogram on its side, surely 7 becomes the base. But, as I said, this is the 5 centimetre line there. So this line here is the straight height. So it's at 90 degrees to the base. So this line here is at 90 degrees to this line here. So that's how I know that this is the base, this is the height. The 7's what we call a red herring. I think a herring is like a fish or something like that. Okay? Hope you guys love fish. So that means that the 7 is actually not important at all. It's just there to trick you. Okay? And I want to trick you because you guys are so smart. And I'm a tricky person. So the area is base, so we're just substituting now. We've done quite a bit of that. We're just substituting base B for 15 and height for 5. Remember, no, we don't just write 155. BH means B times H. So our area is 15 times 5, which is 75. Now remember, when we're doing area, we're doing units squared. So because everything in the question was in centimetres, our answer is in centimetres squared. So the area of this parallelogram is 75 centimetres squared. Okay, easy as. I just want to do one more example for you that's a little bit harder, but I reckon you're up to it. Okay, I hope you're ready for a challenge because this question is quite hard. So without even looking at a diagram, I want you to tell me what would be the perpendicular height of a parallelogram if its base length is 4 metres and its area is 60 metres squared. How can we possibly figure that out? Well, thank God we've just done a little bit of algebra. So one thing I love about maths, and I'm sure you guys love it too, I know you do, even if you don't want to admit it to yourself, is that when I give you a formula, it works all the time. So area equals base times height works for any question involving parallelograms. So why don't we just write that down as a starting point? So area equals base times height, okay? Now, thank God we've done algebra because we can substitute in what we already know. So if area A is 60, I can just write instead of A, 60 equals, now base is 4 metres, okay? And I still don't know H. So I can write an equation like this, 60 equals 4 times H. Now, because you're so amazing at algebra and you love it so much, in fact, you would prefer to do maths on a Saturday night than go to a party or anything, you know that this actually says 60 equals 4 times an unknown number. Or in other words, 60 equals 4 times what? We're trying to find H. The question said, what is its perpendicular height? That's H. So we're trying to find H. So 4 times what equals 60? Well, since you're so astute, I know that you also know that division and multiplication undo each other. So if I want to find what number I multiply by 4 to get 60, I can just go 60 divided by 4 equals H. Okay, 60 divided by 4, nice and easy, it's 15. So H is 15, and it's actually the dimension of one of the sides. So it's in metres, not metres squared, okay? So a parallelogram that has a base of 4 metres and an area of 60 metres squared has a perpendicular height of 15 because 15 times 4 equals 60. How cool is that? We found out one of the lengths of the sides without actually having to draw it. I hate drawing. Maths is so much better. All right, I hope this has been informative for you. This has been the luckiest maths teacher in the world. Have a great day.